Kleinfelder is an employee-owned science, architecture, and engineering consulting firm providing solutions to meet our world's complex infrastructure and natural resource challenges. Working as a team, our bright people will deliver the right solutions.
One of the things which we have in the geotechnical earthquake engineering practice is the full spectrum of the services for that practice, which means that we can provide the assessment of seismic hazards, earthquake engineering hazards, and mitigation schemes to mitigate that hazard. So what it means that we one of the few firms in the nation which we can provide the full probabilistic seismic hazard analysis, which includes seismic source modeling, which can be used to develop site-specific response spectra for different performance levels required for different projects. We also can provide the time histories which go along with that, and spectrally matched time histories that can be used in the actual time history analysis of that facility. We also look into different seismic hazards such as liquefaction, lateral spreading, ground movements, tsunamis, and those things are addressed project by project basis. Challenges the industry is going, as we have seen the recent earthquakes in Japan and New Zealand and Chile, that no matter how much we know, but the earthquakes are that nature that we can't really predict what the next will be, and every earthquake is a different one. And the scientists and the engineers are constantly trying to develop tools as well as designs so that we can withstand those. So the challenges which are going to come in for future for the industry-wide is so that we can, in a cost-effective and efficient way, we can have a design which can withstand and at least take into account the earthquake's loads, but as well as not have a design which is outrageously expensive kind of stuff. So that's where the challenge is, where we can have some kind of intelligent design as needed, and efficient design, performance-based design, which is the more keywords. Recently we've been working on a transportation project. It's a rail project, and it's a very high level project where there was a technical advisory panel involved with the industry experts who were looking over our shoulders, and as well as they were looking at the what can we come up with the solution in a very timely manner in a very short period of time, and within the realm of the project, that it's only going at this time at 30% design, so not the final design. Something which is very quick and also in a sense technically sound as well. So especially it was for a very wide area of the project, which include about 200 miles at this level of linear length. We needed to come up with the ground motions criteria for that entire alignment. So we came up with a solution using some existing data. For example, the US Geological Survey has some data, but that was not directly useful to us. We had to do some kind of a massaging of the data, especially writing small codes to extract the data out of the USGS and develop a very project-specific seismic design criteria to extract the data, interpolate it in a manner that will be useful, and the information useful to us out of there in terms of the ground motion, the seismic design criteria, and present it to the technical advisory panel. And not only did it prove it in the first go round, they very much liked it. So it was very efficient, where we brought our individuals from different offices, their skill sets used in this project, and very efficiently we were able to deliver what is needed for the project. Geotechnical earthquake engineering practice is a unique practice, as it involves all the markets and all the different business directions which Kleinfelder is taking. It includes water, transportation, power, facilities, federal, and examples of the projects are the dams and the levees, high rises, power plants, power transmission lines, bridges, and railway facilities, where very high skills of analysis are needed. So what we're looking in this strategically, that partnering with our market sectors in terms of pursuing those projects which we know are going to be large projects. All of those large projects, especially in the western U.S. and international in the Pacific Rim, and as well as in other parts of the country. For example, we have the New Madrid seismic zone, or South Carolina, Charleston, where we need to have understanding of the seismic sources, understanding of the seismic loads on the different facilities, and designing for those. And there are very few, as I mentioned, very few companies in the country who can do this. So we are very well situated in that. So we are looking into expanding this, especially we are already have a good presence in the western U.S., but we want to expand it to the other parts of the nation where the seismic considerations are of high nature, and internationally where Kleinfelder is going internationally, where the seismic loadings are important, where we can provide our skills and services, and that's what we are planning to do, talking with the different market sectors and different individuals within the company and outside the company to pursue those kind of projects.